Okay, so in this lesson, you're going to learn how to write an equation of a line that is parallel or perpendicular to another line. Now, to do this, we are talking about parallel perpendicular. In previous lessons, you did learn how to write equations of lines. And when we did that, you saw that there were two ways to write an equation of a line. We could have used point slope form. So I'm going to go ahead and write that out. Point slope form, which is y minus y1 equals the slope times x minus x1. All right, so remember when we talked about point slope form, you were given a point and, I'm sorry, you were given the slope and a point on that line. So x1, y1. All right, so that formula here was denoted as, was called point slope form. You also learned about slope intercept form. Slope intercept form. And that was y equals mx plus b, where m is the slope and b is the y-intercept. And that is what we're going to use in these problems in which we're going to write an equation of a line parallel or perpendicular to another. And as we go through this, it does not matter. It does not matter which of these you use. You can use point slope form or you can use slope intercept form. All right, but notice that when using slope intercept form, you are going to have to need the slope and the y-intercept, and when using point slope form, you need to know the slope and a point on that line. Okay, all right, so that's going to be important. All right, so let's look at number one. Number one. So number one, you're given this. You want to know, find the equation of the line through this point here, through 3, 7, which is parallel to this line. All right, so remember, you're told that now you have two lines here. You have this line that goes to this point and is parallel to this line. And just to show you what's happening, I'm only going to do it for this one. But if you were to graph this line right here, if you were to graph this line, here's what you're asked to do. Okay, so you're asked, now here's the graph of this line. So the slope, I'm going to do it this way, y equals negative 3x plus 5. So the slope here is negative 3, and the y-intercept is 5. So the graph of this line, you need 2 points. Well, you know that the y-intercept is 5, so the graph's going to cross the y-axis at 5. So here's the y-intercept right here at 5. And then since the slope is negative 3, that means negative 3 over 1. So the rise is negative 3, the run is 1. So I'm going to go down 3, 1, 2, 3, and to the right 1. So there's the other point. And then you draw your line, and this is what we get. So this right here is the equation y equals negative 3x plus 5. This is a graph of that equation. What we're interested in finding, though, is this. What is the equation of the line that goes through the point 3, 7? So here's 3, 7 here, right here. 3, 7, and is parallel to this one. So there's the point 3, 7. So you want to find the equation of the line that's parallel to it. I'm going to do the best I can with drawing a parallel line. It's going to be quite challenging to do. So I'm going to do the best I can. It may or may not look parallel, but let me just draw it like this. Hopefully it kind of looks like it. So I'm trying to find the equation of that line. That's what you're asked to do. Okay? So remember, parallel lines, what do you remember about parallel lines? Parallel lines have the same slope, right? And so you know the slope of this line. What's the slope of this line right here? Well, that's negative 3. And so then you're going to use that fact, and then the fact that there's that 3, 7 lies on that other line to find the equation of this line. So you're interested in finding what is the equation of this line. That's what you want to know. All right, and that's the idea with all of those. So you're going to be given a line, and you want to find the equation of the other line that's either parallel or perpendicular to it. All right, so let's look at number one. Okay, so here's what you need to know. So when finding the equation of this line right here, you need to know its slope, because notice I can use either point slope or slope-intercept. But notice in both of those, you were given the slope, right? Or the slope is indicated, so you have to know the slope. The important fact is this: the lines are parallel. All right, so since the lines are parallel, the slope is going to equal, and the slope of this line is -3, so the slope of that other line is going to be -3 as well. Slope of since the lines are parallel, the slope equals -3. All right, now I'm going to do it both ways, but in subsequent problems, I'm just going to use this one. It's sometimes easier to use this than this. This takes a little bit longer to do. But for number one, I'm going to do both of those. I'm going to use both of those just to show you it does not matter which one you use. Okay? All right. So the lines are parallel. All right. So the first approach is to use point slope form. Y minus y1 equals a slope times x minus x1. Okay. So to find the equation of this line, to find the equation of that line, you need to know a point on that line and its slope. Okay, and you do. So a point of that line is 3, 7. So you know 3, 7. So we're going to call this x1, y1. And then the slope is -3 since they're parallel. And all you do is just substitute. So we get y minus y1, which is 7, equals the slope, which is -3, times x minus x1, which is 3. And then all you do is get y by itself. So we're going to go ahead and distribute. So I get y minus 7 equals -3 times x is a -3x. -3 times a -9 is a +9. Adding 7 to both sides, we get y equals -3x. 9 plus 7 is going to be, 16? So that's the equation of that line. So the equation of this line right here, this equation of this line is going to be this: y equals -3x plus 16. Okay. All right. Now, it's easy to use point slope form, but I want to show you the other approach. The second approach is to use slope intercept form. So y equals mx plus b. Okay. Now here's the problem. Okay. So when using point slope form, the x1 and the y1 represented that point that was on that line. Okay? All right. So when using slope intercept form, listen carefully, when using slope intercept form, you have to know the slope and the y-intercept. I know the slope is -3, so far I have this. I have y equals -3x plus b. The problem is you are not given the y-intercept. So you got to find it. You have to find that y-intercept. To find that y-intercept, you have to substitute a number in for x and y. And that number you substitute will come from this point. So the point here is 3, 7. So this would be your x, this would be your y. And so then we get 7 equals -3 times 3. X is 3, right? Y is 7, x is 3, plus b. So now we can solve for b. So you gotta solve for b. So that's how you're gonna find b is to substitute and then get b by itself. So I get 7 equals -9 plus b. Adding 9 to both sides, I get b equals 9 plus 7 is 16, which we knew from the other problem. So therefore the answer then, and that's where you go back and resubstitute, your answer then will be y equals -3 x plus 16. So you just so now you know the slope and you know the y-intercept. So listen carefully, say it again. If you use that second approach, you got to know the slope and the y-intercept. All I know is the slope, so I got to find b. I have to find b. To find b, you can use this point right here that's on that other line, and you're going to substitute in place of x, you're going to substitute 3. In place of y, you're going to substitute 7. Once you find b, then you have your answer. Y equals the slope times x and the y-intercept, which we just found to be 16. Okay? So it does not matter which approach you use. Does not matter. Some textbooks will focus on one, some will focus on the other. Does not matter. Okay? All right. Let's look at number 2. In number two, I'm going to just since I don't have much room here, I'm just going to use I'm going to use this first approach. We're going to use the first approach. Um, so so in number 2, I want to find the equation of the line through this point, and it's perpendicular to this line. All right. So these two lines are perpendicular. So remember what that means. That means their slopes are opposite reciprocals of each other. So I got to find the slope of this line right here. Well, it's already in slope-intercept form, so the slope of that line is going to be -1, right? So the slope of this line is going to equal -1, this line here, okay? So what that means is this: the slope of the perpendicular line, that's important, is the opposite reciprocal. Well, what is the reciprocal of 1? Well, the reciprocal of 1 is 1. What is the opposite of a negative? It's a positive, right? So that is 1. All right. So the slope of that line that goes to this point is going to be 1. That's important because remember they were perpendicular. All right. So that's important. Okay. So the slope, I'm going to put slope of perpendicular like this. The subscript is perpendicular. Slope of the perpendicular line is 1. Okay? All right. So now let's use point slope form. So use point slope form. Point slope form. Okay, so I get y minus y1 equals the slope times x minus x1. So in order to use point slope form, I need the slope, which I now know is 1. Okay, so the slope is 1. And the point, which I know is -4, 3. So there's your x1, there's your y1. And you just substitute into here. So I get y minus y1, which is 3, equals the slope, which is 1, times x minus x1, which is a -4, right? Okay, now let's go ahead and simplify this x minus a -4. So y minus 3 equals 1. X subtract a -4 means x plus 4. And then 1, if I distribute the 1, that's still x plus 4, right? 1 times x plus 4 is still x plus 4. So I have y minus 3 equals x plus 4. Getting y by itself, I get y equals x plus 7. And that's it. There's your answer. So the equation of that line is y equals x plus 7. So that's your answer. Okay? All right, that's number 2. It's not difficult. It's fairly simple to do. Because this process you learned in another lesson, you're just using the fact that either the lines are parallel or perpendicular. Parallel lines have the same slope. Parallel lines have the same slope. Perpendicular lines, if they say perpendicular, you got to first find the slope of that line. Then the slope of that perpendicular line will be the opposite reciprocal, and then use that in your formula. Okay, number 3. So in number 3, let's suppose we had this for number 3. Okay, number 3. So you want to find the equation of the line through this point. You want to find the equation of the line through this point, which is perpendicular. So we're doing perpendicular again to this line. Well, first of all, what is the slope of this line right here? Now be careful. I need you to recognize that I can rewrite x over 3 as 1/3 x. That's important to have seen. X divided by 3 is the same thing as saying 1/3 x, because this number right here is implied to be a 1, right? So 1/3. So the slope of that line is 1/3. So since I'm dealing with perpendicular, you would say this. You would say the slope of the perpendicular line, I'm going to write it as the symbol perpendicular line, is the opposite reciprocal. Well, the opposite reciprocal of 1/3 is a -3. All right? Okay. Now, let's use point slope form. So first thing you have to do is find the slope of that line you're interested in. So let's use point slope form first, and we'll do the other one as well, the slope-intercept form. So point slope form, y minus y1 equals the slope times x minus x1, right? So we know the slope of that line I'm interested in is -3, and a point on that line is -8, 1. So there's your x1, there's your y1. And then you just substitute these two knowns into your formula. So y minus y1, which is 1, equals the slope, -3, times x minus x1, which is a -8. Okay? What I would do next, before I distribute, what I would do next is simplify that expression within the parentheses. X subtract a negative 8 means x plus 8. Okay? Then distribute. Y minus 1 equals negative 3x, and then negative 3 times 8 is a negative 24. Getting y by itself, we're going to add 1 to both sides. So I get y equals negative 3x, and then negative 24 and 1 is a negative 23. So there's the equation of the line in slope-intercept form. So I wrote it in slope. I wrote the answer in slope-intercept form. Okay? All right, now let's do the same problem. Let's do that same problem using slope-intercept form instead. Slope-intercept form. All right, so it does not matter which approach you take. All right, so slope-intercept form is y equals mx plus b. Okay, now in order to use mx plus b, you got to know the slope and the y-intercept. All I know so far is that slope, right? That's all I know. So right now I have this. I have y equals negative 3x plus b. And I've got to find this b here. I've got to find the y-intercept. To find the y-intercept, we're going to use that fact that a point on that line is negative 8, 1. So that's going to be your x, that's going to be your y. So you're going to substitute that point, those values of your variables into this equation. So y is 1, so I get 1 equals negative 3 times x, which is a negative 8, plus b. Negative 3 times a negative 8 is a positive 24, so I get 1 equals 24 plus b. Subtract 24 from both sides to get b by itself. 1 subtract 24 is a negative 23 equals b. So there's your y-intercept. So now you know your slope and you know your y-intercept, so therefore your answer will be y equals mx plus b, so negative 3x, and then b is negative 23. And notice that this is the same as this. Okay? All right, so that was number 3. Okay, let's look at number 4. It's not difficult at all. Fairly simple process. Okay, in number 4, we have this. You want to find the equation of a line that goes through this point and is parallel to this line. Okay, so remember, parallel lines have the same slope. So regardless of which formula I use, both of them requires a slope. So I got to find the slope of this line. Well, this is not in slope-intercept form, so I have to get y by itself. So let's see, I'm going to get 3y equals negative 2x plus 6, right? So when you subtract 2x from both sides, that's what you get. Then I'm going to divide both sides by 3, and when I do that, I get y equals negative 2/3 x, and then 6 divided by 3 is 2. So I get negative 2/3 x plus 2. All right? So therefore, the slope of this line right here, this line here, is negative 2/3. So since they're parallel, the slope of the parallel line, which is what I'm interested in, the one that goes through this point, slope of the parallel line is negative 2/3. Okay? All right. So I know the slope of the parallel line is negative 2/3. So let's go ahead and use point slope form. Point slope form, which is y minus y1 equals the slope times x minus x1. Okay, so I need to know the slope, which I do. It's negative 2/3. And I need to know a point, which I do, which is 1, negative 2. So there's your x1, there's your y1. And you're going to substitute those into x1 and y1. All right, so I get y minus a negative 2 equals the slope, which is negative 2/3, times x minus 1. X1. Okay, now let's go ahead and simplify this right here. Y subtract negative 2 means y plus 2 equal, and let's go ahead and distribute this right here. So I get negative 2/3 x. A negative 2/3 times a negative 1 is a positive 2/3, right? Okay, and then we're going to subtract 2 from both sides. So I get y equals negative 2/3 x plus 2/3 minus 2. Now be careful. You don't want to leave your answer like this. You have to go ahead. You have to go ahead and combine those like terms here. So 2/3 minus 2. Remember what that is. 2/3. Let me go ahead and get another sheet of paper out. So 2/3 2 thirds subtract 2, you got to find the equivalent, right equivalent fraction. So the LCD here is 3. So I get 2 thirds minus, and then if this one, 1 times 3 is 3, 2 times 3 is 6. So 6 divided by 3 is 2, right? So 2 thirds subtract 6 thirds is going to be negative 4 thirds. So that's this right here. So I get y equals negative 2 thirds x minus 4 thirds. All right, so that's the equation of the line of this that's the equation of this line here that goes to this point, is this right here. All right, but be careful because you did end up with a fraction here. Now I just want to remind you about something. So I'm gonna do that here. So right here, the way I did it was I distributed first, and then I just added 2 to both sides, and then I wrote equivalent fractions, which is what many students will do. But there might be some of you that will do this. So I'm going to go ahead and use that same page. So I'm going to go ahead back right here, and I just want to show you something. So y, this is y plus 2, right, equals negative 2 thirds times x minus 1. Before you distribute, you could have, if you wanted to get rid of this fraction, you could have multiplied both sides by the LCD, which is 3. So if you do that, you would get 3 times y plus 2 equals 3 times a negative 2 thirds times x minus 1. And then you would distribute here. You would get 3y plus 6 equals, these 3's divide out. That's the whole purpose of multiplying by the LCD, is to clear this denominator, make that a factor 1. And then you would distribute the negative 2, because that's a 1 right here. Let me go ahead and just write it. 1 times negative 2 is negative 2. Then distribute the negative 2. I get 3y plus 6 equal negative 2x, and then negative 2x times a negative 1 is a positive 2. And then getting y by itself, we're going to subtract 6 from both sides. That's 0. I get 3y equal negative 2x. 2 and a negative 6 is a negative 4. Dividing both sides by 3. I get y equals negative 2 thirds x minus 4 thirds, which is what we had here. Okay, so it does not matter. Just to show you, it does not matter whether you distribute first and then just use the idea of adding fractions together from previous course, or at this point, just multiplying both sides by the LCD to clear the fractions, and then solve for y, and you get the same answer. Does not matter. All right. Now, the second approach, remember, the second approach was to use slope-intercept form. Slope-intercept form, which is y equals mx plus b. It does not matter which approach you take. Does not matter. All right. So regardless, though, whichever approach you take, you got to know the slope, which I do know is negative 2 thirds. So here's what I have so far. I have y equals negative 2 thirds x plus b, right? So to get it to the slope-intercept form, I've got to know the slope and the y-intercept. I don't know the y-intercept. I got to find it. Well, to find it, I have to know a point on that line. See that xy? I've got to know a point on the line, which I do. A point of that line is 1, negative 2. So put that here, 1, negative 2. So there's your x, and there's your y. So you substitute, you get y, which is negative 2, equals negative 2 thirds times x, which is 1, plus b. And then simplify this. Negative 2 thirds times 1 is a negative 2 thirds, right? Plus b. And now, if you want to, you can clear the fractions at this point, or you can add 2 thirds to both sides. It does not matter. Okay, so you could say, well, I'm going to add 2 thirds to both sides, just like this, right? And then you would say, well, a negative 2 plus 2 thirds, right? Negative 2 plus 2 thirds. The LCD is 3, right? So you're going to find two fractions, two equivalent fractions with 3 as the denominator. Over here, the denominators are the same, so the numerators have to be the same. So 2 thirds is equivalent to itself. Over here, 1 times 3, negative 2 times 3, so it'll be negative 6. And negative 6 thirds plus 2 thirds is a negative 4 thirds. So I got b to b, negative 4 thirds, which I knew it had to be because of this. So once you find b, then you go back here, right here, and you substitute that number into b, and there's your answer. So the answer will be y equals negative 2/3 x, and then b is negative 4/3, minus 4/3. Okay? Now just to remind you, you remember right here I added 2/3 to both sides, right? But you could have also done this, just to show you. You could have also done, I'm going to put an or here, or you could have also done this. So let me just kind of rewrite this over. You have negative 2 equals negative 2/3 plus b. So you could have multiplied both sides by 3. That's times 3 here. So this times 3, this times 3. To clear the fractions. Negative 2/3 times 3 is a negative 6, equal, and then distribute. 3 times a negative 2/3 plus 3 times b, right? Well, 3 times a negative 2/3 is a negative 2. So I get negative 6 equals negative 2 plus b. Adding 2 to both sides, I get negative 6 plus 2 is a negative 4 equals, this is 0, b. All right? And, oops, I forgot the 3 right here, excuse me. Equals 3b, excuse me. I'm sorry. Equals 3b, I forgot 3b. And then divide both sides by 3, I get b. I'm running out of room here, so I apologize for that. So b equals negative 4/3, which is what we had here. Okay? So it does not matter. It does not matter which approach we take. Just know in this fraction, I mean, in this problem, you did end up having to deal with fractions. Okay? All right, so that was number 4. And then finally, number 5. Number 5, this is what we have. You want to find the equation of a line that goes to the point 2, 0 and is perpendicular to this line. All right, so if I'm going to find the equation of this line here, then I need to know the slope of this line, and we know that they're perpendicular. All right, so first of all, let's get this in slope-intercept form. So I get 4y equals 3x plus 2. So I'm going to add 3x to both sides. So this is what I get. Divide both sides by 4. I get y equals 3/4 x, just like this. And then 2/4 is a half. So I get plus 1/2. So the slope of this line right here, slope of this line is 3/4, right? So the slope of the perpendicular line, slope of the perpendicular line is the opposite reciprocal. So it'll be a negative 4/3. All right, so the slope of the perpendicular line is negative 4/3. All right, so there's where we're going to use the two approaches. Remember, you can use either one. Does not matter. I'm going to do both just to show you. So one approach is to use point-slope form. Point-slope form, right? Which is y minus y1 equals a slope times x minus x1. And in order to use point-slope form, you got to know the slope, which you do. It's negative 4/3. Negative 4/3. And a point in that line is 2, 0. And so there's your x1, there's your y1. So when using point-slope form, you're going to substitute that point into x1 and y1. Not x and y, x1 and y1. All right, so here's what we get. We get y minus y1, which is 0. So y minus 0 equals the slope, which is negative 4/3, times x minus 2, right? Well, y minus 0 is y, correct? And so all you do is just distribute this. So you get negative 4/3 x. A negative times a negative is a positive. Now, some of you may still have a little bit of difficulty with this, but I just want you to remember that when you multiply negative 4/3 times a negative 2, it's a good idea to write negative 2 as negative 2 over 1. A negative times a negative is a positive. 4, you multiply the numerators together, multiply the denominators together. 4 times 2 is 8. 3 times 1 is 3. So that's what I get. So negative 4/3 times a negative 2 is a positive 8/3. Okay? And you already have y by itself, so there's your answer. So that's your answer in slope-intercept form. Let's use slope-intercept form as our approach, slope-intercept form, and hopefully we'll get that same answer. So in slope-intercept form, that's y equals mx plus b. So in order to use this, I need to know the slope and the y-intercept. I do know the slope. Slope is negative 4/3, so I know this. I know this so far is y equals negative 4/3 x plus b. All I got to do now is find this, okay? And so to find this, I've got to use the fact that the point on that line is 2, 0. So let's go ahead and do that. So a point of that line is 2, 0. So there's your x, there's your y. So y is 0, so get 0 equals negative 4/3 times x, which is 2, plus b, right? Well, negative 4/3 times 2, so I get 0 equals negative 4/3 times 2. Do that here. So negative 4/3 times 2, which is 2 over 1, that's going to be a negative 8/3, right? So that's going to be this right here, so negative 8/3 plus b. And then to get b by itself, I'm just going to add 8/3 to both sides, just like this. And so I get 8/3 equals b. And I knew that the y-intercept had to be 8/3 because this was 8/3 right here. All right, so the answer then, and you're just going to go back to this, so you get y equals negative 4/3 x plus b, which is 8/3. So negative 4/3 x plus 8/3. So it does not matter whether you use point slope form or slope intercept form. Some cases this could be easier than this. In some cases this could be easier than this. Okay? And on a worksheet, sometimes students will do it both ways just to make sure they get the same answer. Because if they got the different answers, then something's wrong somewhere. All right, so that is it. It's not a difficult process, but what we were trying to do here was let me go find the original sheet. So what we were trying to do in this lesson was to write an equation of a line that's either parallel or perpendicular to another line. And in almost all problems, in most problems we used, but we did it both ways, to where we used point slope form and slope intercept form. All right, and so that's it. That is the end of this lesson.